Today we are talking about factoring trinomials where a equals 1, or when written out in standard notation, the squared term has a 1 in front of it. So for factoring these, we need to set up a factor sum table. And the numbers that we are going to be using is the last term, which is 24, and the middle term, which is positive 11. We find the factors of the last term, the factors of 24, such as 1 and 24, 2 and 12, 3 and 8. Then we add them together, so 25, 14, and 11, and then we see which one of them is equal to our middle term. So our 3 and our 8 are equal to our 11, and we plug it in to the formula d plus our factors. So we have d plus 3 and d plus 8, and this is our factored term. So for number 2, we should write in standard notation t squared plus 10t plus 9. We find the factor and the sum. Factors of 9, we can use 1 and 9. Sum together would give us 10, which is what we're looking for. And we can just plug it in to t plus 1, t plus 9 are our factored terms. And we can check these by using the O and the I of FOIL, so the outer and the inner. 9t plus 1t would give us 10t. And we look to see if it matches the middle term, and it does, so our factor is correct. Number 3, I want you guys to try on your own, so pause the video and work it out. And you should come up with the factors x plus 3 and x plus 4. Number 4 is a little different because we have a positive and a negative. So we have to multiply two things together to get a positive and add them to get a negative. So we have to have two negatives in this case. So we could try negative 2 and negative 14 would give us a negative 16. Or a negative 4 and negative 7 would give us negative 11, which we're looking for. And this is the same thing, plug it into w plus, but these are, so it would be a w plus negative 4, which you can just say is w minus 4, and w minus 7 are two factored solutions. Number 5, we should write in standard notation. So we have m squared minus 22m plus 21. Find the factors that give us positive 21, negative 1 and negative 21 add together to be negative 22. That's what we're looking for, so we can just plug it in. M minus 1, m minus 21. We can check this by doing the outer and the inner. Negative 21m minus 1m gives us negative 22m, which matches the middle term. So these are our two factors. Number 6, I want you guys to try on your own. So pause the video, and you should get the factors of x minus 3 and x minus 9. Number 7, again, is a little different because this time we have a negative last term and a positive middle term. So in this case, we have a negative and a positive factor, but we want the larger factor to be the positive, so it gives us a positive middle term. So we're looking for factors of 48. We can do 24 and negative 2 would give us 22. Or 16 and negative 3 would give us a positive 13, which is what we're looking for. Plug it in to y plus 16 and y minus 3 are our factors. Number 8 again is a little different because this time we have two negatives. It's going to be exactly the same as 7, except we want the larger factor to be the negative this time. So we're looking for factors of negative 24, such as negative 8 and 3 would give us negative 5, or negative 6 and 4 would give us negative 2, which is what we're looking for. And we plug it in, r minus 6, r plus 4, and we can check this. using the outer and the inner. So we have 4r minus 6r is negative 2r. And that's what we're looking for in our middle term, so we know our factor is right. I want you to try 9 and 10 on your own. They're exactly like 7 and 8. So you should come up with x plus 6 and x minus 3 for number 9 as your factors. And number 10 should be x minus 5 and x plus 4. So now we are going to talk about solving quadratic equations. And it's an equation in the form ax squared plus bx plus c is equal to 0. When solving these equations, there's a couple steps you have to follow. The first is getting 0 on one side of the equal sign and everything else on the other. The second step is to factor in the way that we just talked about. The next step is to set each factor equal to 0 and solve for the variable. And the final step is to check your solutions to make sure that they work out. So for our first problem, we have x squared plus 3x minus 18, and we can factor that using a factor table. And we could use 9 and negative 2 would give us negative 18 and a positive 7. 6 and negative 3 would give us a positive 3. So that's what we're looking at. So we can factor our x squared plus 3x minus 18 into x plus 6 times x minus 3. And that's equal to 0. So now we can set each term equal to 0. X plus 6 equals 0. Or x minus 3 equals 0. Solve each equation for x, so subtract 6. X equals negative 6. Or in the second equation, add 3. X equals a positive 3. So now we want to check these solutions to make sure that they both work. So we plug it into our original equation and make sure that they're both equal to 0 by plugging each of our x's into the equation. So we can start with negative 6, so we have negative 6 squared plus 3 times negative 6 minus 18 gives us 36. Minus 18 is 0, which checks out. And then plug in 3. So 3 squared plus 3 times 3 minus 18 gives us 9 plus 9 minus 18 with a solution of 0, which also checks out. Number 12, we have z squared minus 3z equals 70. We need it equal to 0, so we can just subtract 70 from both sides. And we have z squared minus 3z minus 70 equals 0. Now we can use our factor table to find the factors. We can try negative 35 and 2 gives us negative 33. Negative 10 and 7 gives us negative 3, which is what we are looking for. So the factors are z minus 10 times z plus 7 equals 0. Now we can set each term equal to 0, z minus 10 equals 0, or z plus 7 equals 0. Solve for z on each equation. Z equals 10 is our first solution, or z equals negative 7 is our second solution. And again, we should check these by plugging it into our original. Z squared minus 3z equals 70. Plug in both terms so we can start with 10. We have 10 squared minus 3 times 10. 100 minus 30 would give us 70. And that checks out. And then we can plug in negative 7 to our original equation again. So we have negative 7 squared minus 3 times negative 7. Or 49 plus 21 gives us our 70. So both solutions work. Number 13, I want you to try on your own. So pause the video and try to work it out. You should get the solutions of x equals -5 or x equals 3. Number 14, Mark wants to build a new art studio that has 3 times the area of his old art studio by increasing the length and the width by the same amount. The length of the old art studio is 12 and the width is 10. So we want to have an area 3 times the original, so we can find the area by multiplying the base times the height, which would give us 120. We want to multiply this by 3 to give us the area of the new building, which would be 360. And the equation or the word problem says that we're increasing the length and the width by the same amount. So if we add x to both the 10 and the 12, we're adding the same amount to both the length and the width. So now to find the area of the new building, we take our area, which we found to be 360, equals our base of 12 plus x times our height of 10 plus x. And we can use our FOIL method that we've learned before. So we have 120 plus 12x plus 10x plus x squared. And now we want it equal to 0, so we can subtract 360 and combine the like terms as well as putting it in standard notation. We have 0 equals x squared plus 22x minus 240. And we can put this into our factor table. And try factors like 30 and 8. -8 because we need a negative 240, not 24. And that would give us a positive 22, which is what we're looking for. So 0 equals x plus 30, x minus 8. Set each factor equal to 0, x plus 30 equals 0, or x minus 8 equals 0. Solve each for x equals -30, or x equals 8. And now we have to think about the problem, and we have a negative number, and we can't have a negative length, so -30 is not going to be a solution. So our solution is x equals 8. And we're finding the dimensions, so we add 8, substitute 8 in for our x. So 12 plus 8 would give us a new dimension of 20 by 18. And number 15, the height of a parallelogram is 18 centimeters less than its base. If the area is 175 square centimeters, what is its height? So I want you guys to work this through on your own. The area, I'll give you a solution of the area, is base times height, where in this case, this is our height, and our base is here, and our height is 18 centimeters less than the base. So b minus 18 is our height, and our base is b, so you guys can solve this. And you should get a base to be 25 centimeters. So our height is 25 minus 18, or 7 centimeters. And that's the lesson for today.